Okay, now that we know how to find all the factors of a composite number and how to find prime numbers, let's step it up a notch.
Section C, the greatest common factor.
The best way to introduce the greatest common factor is to pick a couple numbers and factor them like we've been doing. The greatest common factor is going to be the factor with the highest value, or largest quantity, that appears in both lists of factors. Let's try this with the numbers 15 and 20.
Our first step is to factor both our numbers. We're going to do the listing method this time, so let's list the factors of 15 and 20. The factors of 15 are 1, 3, 5, and 15. And the factors of 20 are 1, 2, 4, 5, 10, and 20. The next step in finding the greatest common factor is to figure out all the factors that these two numbers have in common. In this case, we notice that 1 and 5 are in both lists, so they're called common factors. Now remember, the greatest common factor is the one out of these two that has the highest value. In this case, the greatest common factor is 5 because it's a common factor of 15 and 20, and it's greater than the other common factor, 1.
Another thing to know about the GCF is that it's possible the GCF of two numbers will equal 1.
For example, with the numbers 7 and 15, 1 is the greatest common factor, because after we factor them out, we see that 7 and 15 have no other factors in common. So, 1 is both their only common factor and their greatest common factor.
Since we found the GCF in our previous examples by listing factors, now we're going to try another way. Remember way back about 3 minutes ago? We used the tree diagrams to do prime factorization. Well, we're going to use that same prime factorization stuff to help us find the GCF another way. Let's take a look.
Say we're searching for the GCF of 12, 28, and 48. First, we're going to factor them down to prime numbers using the tree diagram, and then put them into numbers with exponents. So, starting with 12, 12 breaks down to 6 times 2, which further breaks into 3 times 2 times 2, or 3 times 2 squared. 28 equals 14 times 2, which breaks into 7 times 2 times 2, or 7 times 2 squared. And 48 equals 12 times 4, which breaks into 4 times 3 times 2 times 2, which equals 2 times 2 times 3 times 2 times 2, or 2 to the 4th power times 3. Now let's figure out the GCF.
After we get the prime factorization, we've got to look at the numbers and their exponents and figure out which will be a part of the GCF. Any prime factor we choose for our GCF must be a factor of all three of the original numbers, because that's what makes it a common factor. So, when we look at the prime factors, we see that 2 is the only one that's a factor of all three numbers. So it's going to be the lone base number in our answer. The only thing left is to figure out what exponent 2 will have.
When deciding on the exponent, we look at the exponents for each of the 2's. We've got 2, 2, and 4. To get the GCF, we just take the smallest exponent. So in this case, we would use 2 as our exponent. That means our GCF is 2 squared.
So, our GCF, 2 squared, equals 4 when we multiply it out. 4 is the greatest common factor of 12, 28, and 48 when we express the GCF in whole numbers.
A great way to check our work is to list the factors like we did in the first method and see if we got the same answer. See how when we list out the factors in whole numbers, 4 is the GCF. That means we did our factoring correctly.
So, when we're looking for the GCF, first we want to get the prime factorization of our numbers. Then figure out which prime numbers are factors of all our original numbers, and how many times each of those prime numbers is represented. Then, we take the smallest exponent, and we've got our GCF. Now we're going to take a look at something that's kind of like the cousin of the GCF, but with its own identity.